So now that we've looked at exponential functions, we are going to have to find the exponential equation. So there are two ways to find the equation when we're just given the points. By hand, using your math skills, and by using a regression on the calculator. And I'm going to require you to know both. So that means at some point when we take a test on this, you are not going to have your little calculator. So we're going to start off with the easiest one. Given an exponential function in the form f of x equals a to the bx, it is known that, here we go. We know 2 points right here. We know what happens when we put 0 into the equation, and we know what happens when we put 3 into the equation. Now, we have to find that equation. We like this one because we have a great clue here. We know what the answer is when it's raised to the 0 power. That's very powerful. Believe me, you will learn to appreciate that by the end of this lesson. So the first thing I want to do in my mind is I just want to get things straight here. I put a 0 in for the x. They're telling me the answer is 8. And if I put a 3 in for the x, they're telling me my answer is 1,000. Now some of you may see the answer already, because these are pretty easy points. It's example 1. But we're going to still go step by step. So that means basically this is what your brain wants to think. That's what I'm trying to figure out. And right now I know that 8 is the answer when I put a 0 in. I don't know what A is, and I don't know what B is. Now, your brain can go here and say, well, this is not that bad because anything to the 0 power is 1. Times that by A, that should get me 8. A times 1 is A. So, hey, there's my first clue. I mean, I have to find the A and the B of this equation. So my A must be 8. Well, what's my B then? I'm still trying to figure out what my B is. That's when we can use the second clue. I know okay, yeah, I know the screen changed because I had to do some editing, and well, this is where we're at. So just deal with it. So we got to find that base. It's all about that base, You know it was coming. Anyway, I know I'm going to use my third point here. When I put 1,000 in for the y value, I know that A is 8 and B was raised to the third power. Okay, so now all I have to do is solve this. I'm going to divide both sides by 8. And I'm actually not going to divide 1,000 by 8 because I see something that's really nifty here. I see 1,000, I see 8, and I'm left with b cubed, meaning the only way to get rid of a cube would be to cube root, and I thought ahead because 1,000 and 8 are both perfect cubes. So the cube root of 1,000 is 10, and the cube root of 8 is 2, so the base must have been 5. So if I'm going to rewrite this equation now, I have all my clues. This exponential function has a principal of 8, a base of 5, raised to the x power. Okay, in example 2, it gets a little trickier. So tricky that I couldn't spell that correctly. We're not going to have pretty zero powers to give us a clue anymore. We are told it's an exponential function. So right away, our brain can go to the exponential function. And then they give us two clues. They tell us that when we put a 4 into this function, our answer is 3. And when we put a 6 into this function, our answer is 48. So let's find the equation. Well, I'm going to start with my first thought process here. And I should know that this is an increasing function. Right? When I went from 4 to 6, my end result went from 3 to 48. It's increasing. So therefore, my base is going to be greater than 1. At least we know that much. So let's find that base. Since it's increasing, here's the trick to this. When I put 48 into the function of some principal times some base, it was raised to the 6th power. When I got 3 as an answer in the same function with some principal and some base, it was raised to the 4th power. Well, what I'm going to do is I'm going to divide these two equations out. There I am, I'm dividing. Well, 48 divided by 3 gives me a very nice number, 16. And look at the happiness that comes here. A and A cancel out. B to the 6th divided by B to the 4th is B squared. So my base must be 4. Awesome. Go away, base. You are the number 4. Now, how am I going to find my principal, my initial amount? Well, that's not that hard now because I can choose any one I want. I can say, all right, 48 was obtained by taking some principal, multiplying by our base, which was 4, which was raised to the 6th power. Now, before you grab your calculator, obviously we're going to divide by 4 to the 6th power, but you can make this life a little simpler on you. Because remember, I said you're not going to have a calculator at some point. Well, 48 is 4 times 4 times 3. 16 times 3 is 48. And 4 to the 6th is 1, 2, and then 4 more. So these 4's cancel out. So it's 3 over 4 to the 4th. And that's 16 times 16, because 4 to the 4th is 4 4s. 2 4s multiply 16, 16 times 16. And then whatever, 3 over 16 times 16, well, that's a perfect square, and that is 256. So let's check. 3 is not going to go into 256 because this bottom here was just made up of 4s. So there's no way you can cancel. So after all this messy page, I found that my A value was 3 over 256. So yes, so you're going to get some wackadoodle answers now. Same thing here, except now they're going to give it to you in a word problem. A bacterial colony is growing at an exponential rate. There we go, exponential rate. We know that is f of x equals our principal times a base raised to the x power. It is known that after 4 hours, okay, now they're start to giving our points. The population is 98. So we have to understand that as when I put 4 into this function, the answer is 98. After 9 hours, it's 189 bacteria. So when I put 9 into this function, I get an answer of 189. So immediately my brain knows that this is an increasing function because our numbers are going up. So our base is going to be greater than 1. That just helps get our mind straight. So determine an equation that models this population Y, and X is the number of hours. All right, so we're going to have to do the same old again. Since it's growing, I'm going to start with 89 is found by taking the initial population and raising the base to the 9th power. Well, 98 was found by taking the initial population and raising the base to the 4th power. Once again, I am going to divide, and I'm dividing because exponential is multiplication if you haven't figured that out. Well, this cancels out, and that gives me b to the 5th. 9 divided by 4, I subtract. All right, 189 divided by 98. Guess what? I am not going to do that and get a decimal. I know I have to take the 5th power, so I have to take the 5th root to solve it. Now I'll get out my calculator, and I'll let the calculator do all the work. I'll say, go into math. First, I'm going to press 5. I'm going to go into math, and I'm going to choose choice 5. There, now I'm taking the 5th root of 198 divided by, what was that, 89? Oops, sorry, backwards. It's 189 divided by 98. Now, I am going to get an ugly decimal here. That's obvious. Let's see, did it tell us to? Nope, it didn't tell us where to round, so I'm going to go to the nearest hundredth. So I'm going to say my B was approximately 1.14. I'm going to use that now to figure out my principal amount, because they didn't tell me how much I started with at the 0 hour. Come over here. And I know I can use any point I want, so I'm going to use the 98. 98 was the answer for my initial population. Now, if you really want to be fancy, you could actually put in the 5th root of 189 divided by 98. Or you could use 1.14, but I'm going to be fancy. And that was raised to the 4th power. Because if we did power over root, 189 over 98, power over root would be raised to the 4/5. All right, then to get A, I would divide by 189 over 98 raised to the 4/5. So I could come over my calculator. I can say 98 divided by parentheses. I won't have to go in math, actually. $189 divided by 98 raised to the 4/5. And my answer, 57.9. So I'm going to say A was 57.9, so we could say it was 58 just to make this. So if I wanted to write this as my final equation, I would say it was a function with an initial population of 58, a base of approximately 1.14 raised to the x power. And tomorrow we'll go over the regression on a calculator.